Hey everybody, let's look at an application from the hyperbolas. Make sure you've read that information before you started this video and tried to process it enough. Hopefully after the video this will make sense. So another thing to keep in mind is that all the points that are of where the strike could take place, such that the time difference would be the same as for the first strike, would form a hyperbola with you and a friend as the foci. So the key to this is that the foci are going to be where my friend and I are going to be, where we're going to be standing. And the other thing, I'll just say it now too, is that the difference of the distance from the point on the hyperbola to me and from the point on the hyperbola to my friend is going to be a constant. And so that constant is 2 times a. If we can find that value of a, we'll be on our way to figuring out how far the lightning strike occurred. So let's look at the problem. You and a friend are talking on the phone. Your friend is 4 miles due west of you. You hear thunder from a lightning storm, and then 18 seconds later your friend hears the thunder. If the lightning strike is known to occur due north of you and sound travels at 1100 feet per second, where did the lightning occur? Where did the lightning strike occur? Well, let me start by just getting my bearings straight. Never eat shredded wheat. And so my friend is 4 miles west of me. So that means if I say M is for me, and then F is for my friend, we know that these are going to be the foci, and that this distance is 4 miles. So we're thinking about this as F1 and F2. And the lightning strike thunder was directly above me. And so here's my sketch of lightning. Ooh, pretty good. All right. And we know that the friend hears it 18 seconds later, but the speed of the sound, so the speed of sound is traveling at 1100 feet per second. And so I have a unit mismatch. I'm going to go ahead and convert the 4 miles to feet. And there is 5,280 feet in a mile, so I'm going to need to multiply this by 5,280 feet, which is going to give me 21,120 feet. All right, so that's telling us that the distance between the foci is 21,120 feet. If we're picturing this on the curve, remember that, let's just draw some branches. And the foci are inside of the hyperbola, right? On the ellipse, the foci were inside, but the hyperbola, similar to the parabola maybe, you can think about it as that they're on the inside. So we know that this whole distance is 21,120 feet. We use C to denote the distance between the foci, so 2C would equal 21,120 feet, and if we want to know what C is, it's going to be 10,560. So just the distance from the origin to to me is the 10,560. All right, so where do we need to go from here? Okay, we know that the friend hears the lightning 18 seconds later, and so we need to know what that distance was from where I was standing. So, because this is the friend and this is me. wait, it's not the distance from where I am standing. What I'm interested in is the distance, this vertice of where the branch crosses the x-intercept. So this is where we're coming from, that the difference of the distance on the curve to me and the curve, and from the curve to the friend, is that constant 2a, and that's corresponding to this a here. So if we have that lightning was heard 18 seconds later and we know how fast it travels, then that means that 1100 feet per second times 18 is going to give us 19,800 feet. Which is telling us that it's the distance between the vertices that are on the branch. And so since the difference of the distance from point on the hyperbola to me and the point on the hyperbola to a friend is a constant, it's going to be this constant 2a. So 2a will equal 19,800. When we solve for a, we'll end up getting 9,900. And this is in feet. And so from this point, we can use our use the fact that b squared equals c squared minus a squared. A squared to help us solve for b. And so when we plug everything in, c squared is going to be 10,500. Whoa. 10,560 squared minus 9,900 squared. And when I punched this into my calculator, I came up with 13,503,600. And so we need to, well, and that's b squared. And so that's basically telling us how high up here we are to to, like, I guess find the asymptotes, if you want to say it that way. So what we can do from here is we can write the equation of the hyperbola. It would be x squared over our a squared. And so let's just write it as then minus y squared over the answer we just got. And it equals 1. And so since we know that this distance is where I'm standing, we need to know what the height is for when x is 10,560. So, because since the lightning strike was above us, when x is 10,560, we can know where the lightning strike occurred, how high above us the lightning strike occurred. And so what you want to do is plug in x equals 10,560 and solve for y. Alright, so I just wrote this out. We're plugged in 10,560 for x, because that's going to be the point where we know the lightning strike occurred above us. And so when you solve for y, it's just a lot of big numbers here, and we end up with y equals 1364. In other words, the lightning strike occurred at 1,364 feet north of me. And so this problem is all kinds of, it's just paying attention to the nuances and knowing, I think the key part is knowing that part in the notes where we come up with saying that the distance from the point on the curve to me to the point on the curve to the friend is that constant 2a, because once we were able to find a, we can find b to write that equation of the hyperbola to allow us to know what the height was, since we knew how far, knew my location of where I was at, being the 10,560. All right, I hope you found this helpful. Later.